Hello and welcome to this another week of our online lectures on multimedia. And from this week, we will be learning very vital concepts in multimedia, and that is multimedia communications and networking. And in this week, we'll be trying to cover services and protocols. If we can finish some part of it, it will be going to the next week, and it will be continued in this way. So as you see that we are dealing with text, audio, video, and animations, lots of different kinds of data. And in this world, this very hyper connected society. And when you have the data in your devices or in your computer, if you don't transmit this data to somewhere else, basically that data has no meaning. It's just consumed by you. And a big part of our multimedia is basically taking place over the networks. So when we talk, when we do the video conferencings, or even simply watching YouTube videos and various other kinds of services that we do, it's all happening over the networks. So that's why we need to pay special attentions on multimedia communications and networking. So let's see that how much we cover. So the contents that in these chapters that I'm saying, multimedia communications and networks, services and protocols, we'll be trying to see something on general communications. So that is protocol layers, protocol layers and of computer communication networks, and we'll see local area networks and access networks, and internet technologies and protocols. So these are usual communication scenario, and if you already have an idea, it will be review for you. Generally, in each of the basic networking courses, they cover these things in the beginning. Also, in communication course, you should learn this. But then to relate these things with our multimedia understanding, we need to start with these conventional techniques. So the first part, that means this part, will be somehow review related to communication networks. So if you like to understand in more details, definitely you need to study from the book or other resources, as I always say that. Now the second things that this is this one. After we have the review, then we will see the quality of services for multimedia communications and protocols for multimedia transmissions and interaction. Okay, so yeah, see, what is this one, this diagram? This diagram is saying something kind of that how our simple home or office network setup looks like. Yeah, and so maybe it's better to start from here. You perhaps most familiar in every day you are using that this kind of Wi-Fi router, right? So this is kind of Wi-Fi router, and if you see closely that it has some wired connections, that the wired connections you can directly connect by a wire to your computers or laptops, and these things over here, these things, these are basically some antenna. It gives you the Wi-Fi signal and or wireless signal that that using that wireless signals or Wi-Fi you can use computer, right? So this is this Wi-Fi router. But maybe you also noticed, but lightly, that this Wi-Fi router is ultimately connected to something like this kind of modem. This is called let's say cable modem or something. Okay, and these cable modems is connected to the real internet service providers. So this is exactly the same thing that we are saying here, that we have this ADCL and this router over here. And this router basically, used for switching purposes, that from, I will tell this, about this router a little bit later more. But anyway, this router sometimes, and very often come with something called firewall. The firewall basically security stops and software, you can say. The security software verifies that what kind of networks information is going out of the networks and to the networks, so that some security can be provided. And this router itself doesn't provide any internet, so we need this as I mentioned, this cable modem, or let's say ADSL modem, some sort of modem. This modem connected to our ISP, so ISP provide the internet, and this internet basically coming to our home through this modem, and this router is used for routing our informations, that which website want to visit, which website not, and what is some sort of security also. This is coming from the firewall, and part of the firewall is happening in our device, occurred in our devices. So this is very much a connection diagram. So this is basically the let's say the access point. That means this router, we are saying this router itself is an access point. Then we are getting the internet in our computers, in our mobile, this kind of things. And if we connect through direct through network port, then we say maybe an Ethernet technology. We will see shortly on that. And other things to need to mention, that see this one, this is basically if you see which one is router and which one is not, you can see if you see this kind of things, perhaps this is more chance that you are basically looking at the modem, because this is basically cable modem. How it looks like is coaxial cable. Okay, so we are not spending much more here. The things we understand that this is a typical home network setups. So we have the ISP for providing internet, and we have the modem to access the internet from the ISP, and to route and to set up the networks we need this router, and then we are getting the internet either through Ethernet technology or simply Wi-Fi just as wirelessly. So this is the summary. Now how these things happens, I mean the entire things, this is not an easy and simplified job. It's basically a messy jobs that someone sending the information and someone receiving the information, and it going through or over the networks. So that means many paths in between, right? So to make the things simple, we can think of something called OSI model. The OSI model is not any kinds of or practical or any implementation perspective. It's not the real things. It's all about the logical thing, or you can say conceptual idea that how internet communications from one device to another device works. So this exchange of information, how we can make it possible, and this is a big job. So these diagrams, these conceptual models, tells us about that. So this is exactly we are saying OSI 7-layer model. And if you are a network guy, and if you want to know the networks, that how it works, all you need to start with this OSI concept. It's a conceptual model. It's not necessary that you will have to follow exactly like this, but this explain and simplify that how we understand communications, or let's say if our job is to send in information from the transmitter and receiving that information at the receiving end or at the receiver, then how we can transmit this information from here to here, or how we can receive this information from transmitter. So this is the big job. Now this big job can be divided or splitted into 7 smaller tasks, we can say in this way. So that one task is basically called one layer. Okay, now don't be afraid of this diagram. It looks messy, but I will try to explain in a very simplified way. So, and as an example, so if you understand this example, I believe that this idea and these explanations will be helpful for you in your other courses and throughout your life and lifelong, I would say. Okay, so see, think about that. Let's say this application layer, we can think of that someone, maybe the big boss or someone. Okay, now this big boss is saying that, hey, we have 500 pages of data. So this, I'm talking about this one, this guy, okay? This one, number one. So this is the big guy, and or maybe a company CEO or something. So he's saying that we have to send this 500 pages of information to this guy over here, okay, to the receiving end. Now, let's say he just immediately, tells these things to, this guy, okay? So this guy, let's say we are saying presentation layer. Now forget about the name. Let's say he's the CEO. He's telling that send this 500 page information to, to this guy, okay? Maybe this guy is maybe in some other city, maybe other country, maybe Japan, in Japan, Tokyo, okay, Tokyo. And maybe this, guy is in Korea. So, or maybe company in Japan, and maybe this company is in Korea, something. We can think in this way also, okay? Now, he's sending to his subordinate from this guy to this guy. So now is his job, right? Now it says, okay, now I have this 500 page documents, and I'll have to send this 500 documents, to this guy. But the problem is, this guy over here in Japan, he doesn't understand this document language. Maybe this document language is 500 page document language. Originally, maybe, I don't know which language, maybe let's say Spanish language, okay? Maybe Spanish language, or maybe Korean language even. Okay, maybe Korean language, but he doesn't understand this language. So this presentation layer, what I'm saying, let's say this guy, what he do, maybe let's say translate, or in another word, he basically, change the format of these entire documents, and then he thinks that, okay, now, these translated documents or maybe newly formatted documents will be understood by this guy, okay? So that's the idea. So very first things we had this 500 page documents. Now this guy translate, or maybe something called new formation, and then the session layer. So that means this guy, okay? Now, okay, this translated 500 page documents, now translated. Now this translated documents come to this guy over here, okay? Now what is D? Okay, I'll have to send this now. So he tells, okay, this guy over here, he tells to this guy that I have done this translation. Now send this to this company over here in Japan. Now it says, okay, I got this in 500 page documents, and this company over here. So immediately what he does, he tries to contact with this counterpart over in this company, okay? And let's say this counter guy is here somehow, okay? And this guy, he tells, okay, hey, how long that your company will maybe open, maybe up to 7 p.m. or 6 p.m. I need to send the documents, so can you wait for me, or maybe can I send this now? Now he says that, okay, you can send. Then he says, okay, when you get the documents, please let me know. So this kind of agreement between these, to establish a connection or session between this company and this company. And he waits somehow that, okay, until he gives the acknowledgement that, okay, I got these documents. He tries to maintain this kind of connections between these two. So now the simplification thing is that 500 page was given by him and then translated by him, and then he tries to communicate someone over here that I and make him aware that I like to send the documents, and please you be wait, and then when you get it, let me know. Okay, so that's the thing. And then he guy says, okay, I have contacted the other guy and he's ready to receive the information. Now what you do, you please transmit this information. Okay, so this guy, he's saying to this transport layer guy that do this. Okay, now transport layer guy, what is that? Okay, 500 page documents. It says that 500 page documents I'll have to send to this node over here. So how can I do that? So he thinks that, okay, this 500 page documents, if I send or data, then at once, if something problem happen, it will be a problem. How I can send it again? So rather what he does, okay, maybe it's better, I do maybe 100 page document, and then 100 page document, and another 100 page documents, another 100 page documents, another 100 page document, like that. So he says, okay, envelope 1 is 100 page document, envelope 2 is another 100 page document, envelope 3 another 100 page document, envelope 4 and envelope 5. So basically, this transport layer guy doing that, okay, he got these translated documents and he knows that other party is ready to accept. So what he does, he basically segmented this entire document into 5, segments. So each segment is 1, 2, 3, 4, 5. And now we say, okay, so now these segmented documents, goes to here in the network layer. In the network layer, what does it do? So let's say this guy, now his job is to, so this guy transport layer, he says, okay, I have now, I am now giving you this 5 envelope. Now these 5 envelopes you send to, that person, okay? So he now see what is it, okay, which person? So what does it do? He basically took, okay, from this guy, take this envelope 1 and send to this guy 2. So this network layer, what it does, take each envelope and provide the from address and to address. So only these jobs, okay, some addressing things is done by this one, and then it is now sent to this here. Now the guy over here, he says, okay, now I understand that I'll have to send this envelope to this guy, but it turns out that this envelope is kind of open. So if something happened, if some problem happened, how I know that some problem happened, I'll have to recover that information, or maybe if someone cannot read it. So this guy then what does it gives some seal onto this envelope, okay, and see that if this seal is not read and opened by someone else, only by the designated person, okay. And after that he said, okay, I have this sealed envelope, and that's now sealed envelope will be sent to some final person. This final person will say, okay, go, but it tells that, okay, maybe you can go by motorbike, or you can go by maybe aeroplane, or you maybe go by car, something like that. So finally this information go by physical media, and it goes over here, okay, up to this point. Now this data link layer in this side, it says that, okay, this is envelope, this is to address, for address, and it also is sealed envelope, so that means it is right. So it goes in the network layer. Now network layer, it says that, okay, network, it says that, okay, this is my true address, from address, everything was perfect. So yes, this is for me, and goes to the transport layer. Now in the transport layer, at this receiving side, it says that, okay, so I am so there are 5 envelopes, and I received all the envelopes. So this is the correct order, 1, 2, 3, 4, 5. Maybe it receives in different order, but it now correct the order, okay. Now to the session layer. Now in session layer, okay, he said, oh yes, I was supposed to receive these documents, now I got it. Now when I got it, it now immediately send this acknowledgement to this session layer that, okay, I got it, okay. And then it now eventually is again maybe required some translation or retranslation it do, and then finally got the information back. So this is how this OSI model works. So I believe that if you think about in this way, so this is somehow it will be helpful for you to conceptualize that how communications happen between one device to another. But again, this is simply a conceptual idea, okay. Now think, when this information is basically going down from the sender to receiver, now definitely if you think in this way, then this is layer 1, this is layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. Now if you think in this way from the receiving side, definitely this is layer 1, this is layer 2, 3, 4, 5, 6, 7. So now you remember that. Now there's another perspectives that I need to say, that that when this segmentation is happening over here in the transport layer, as you know, that segment segment, that's envelope 1, 2, 3, 4. This is, we say we say segmentation, okay. So that means before we are saying the data from application layer, but now we are saying segment 1, segment 2, that kind of things. Now when this segment goes to the network layer, we say those are basically packets, okay. So that means network layer basically take the segments from the transport layers, and then it just say that, okay, this is now my packet 1, packet 2, packet 3, something like that. And in the data link layer, we say this is frame, okay, frame. So this is, some things that how to say. So this is basically data, this is segment, this is packet, this is frame. This is how we say it, okay? So I hope that you understand it. Now you see there are some other kind of things we are saying these things here, right? See, originally we have data, right? Now when this data, we are working, let's say we just go to the next page. Well, this is, something like in details, some words that if you want to make a note that what is done by the physical layer, data link layer, network layer, that all I have explained. Now here, we'll be coming back to this page again that I was going to explain. So this is the OSI model, as you see, application layer, presentation layer, session, transport, network, data link, and physical layer. But then, this is basically conceptual. This is, it depends on you that how you conceive and how you implement. Now, one way to implement this is basically TCP/IP. This is TCP/IP means, this transport control protocols, or maybe let's say internet protocol, something like that. We'll study these things a little later on. But now we can see that an analogy between this, these structures and this structure. Here you see that application presentation and some part of the sessions we are saying application protocol. And this transport protocol is in TCP/IP, this transport protocol, and part of the session layer is transport protocol. And this is, we are saying internet protocol, and this data link layer here is, we are saying LLC and MAC in TCP/IP. And the physical layer is also the same. And roughly speaking, in application layer, whatever we do, so that we are saying that our physical information, how we get it, definitely we need to some interact. When we, in our computer we are working, let's say some Word file we have to transfer by Gmail, or maybe just we'll, download some document from a server. So we need to connect through the, something called, some website. So we then connect with the browser, that is HTTP, Hypertext Transfer Protocol. If we download a file, then file transfer protocol. If simple, mail protocol, telnet, there are different kinds. So those are basically application layer. And here, so that means, this example over here, this is basically, let's say HTTP, something like that. Okay. Now this transport layer job, sometimes you want to have very, guaranteed, transportation, guaranteed communication. So that times we say, something called, connection oriented, service. And sometimes you just want to send the data, but you are not waiting for the, guarantee that it delivered or not. There are certain, situations when we are okay with that. So this is basically connection list, protocols, and we say UDP, user datagram protocol. And internet protocol, for example, so IPv4 is basically internet protocol. And then other, network access, that is we have some Ethernet, token ring, those things. And physical layer, maybe fiber channel, or maybe this kind of, network name, 100 base T. This is basically a simply standard of networks. Okay. So these are, some of the comparison between your OSI and the TCP/IP model. But as I explained, the TCP OSI is basically conceptual things, and I believe that the way I explain it will be helpful for you. Now, so we are here, right? So see, so we had the data. Now something happening in application protocol, let's say HTTP or something. So this is, you have the data, so you attached with some sort of, some information related to application layer, and this is called application header. So that this presentation layer know that, by looking at this, header information, he knows that what he needs to do. And then after doing his job, the instructions he will be putting, this is called presentation layer header. And after doing his instruction in session layer instructions, that means, as I'm saying that the guy, right? This guy tells some instruction to this guy. So this is basically session layer header. So that means at each, layer, some additional information is coming. So this is, transport layer header, network layer header, data link layer header, right? So at each layer, in addition to the data, so that's why you see our data initially was like up to this, but now at this layer become like that, and this become like this, because at every layer we are adding some header information, so that the lower layer or upper layer, it knows that what he will have to do or what information he's getting from the other layer. So this is the idea. Okay, so I believe that this explains all. Now let's say talk something on something called these local area networks. You know that what is local area networks. I don't need to understand that. I'm just going directly to the LAN standards. There are different kind of standards. One is Ethernet standard, and that is widely used. This is 802.3, and then we have wireless LAN, that is 802.11. 802.3, what is this? This is basically something called IEEE standard. It is some sort of standard, and standard is a very common guidelines based on which we work, or some particular device. For example, if you go to the market and you like to buy a wireless LAN card, or maybe Ethernet card, network card, so you need to maybe you are buying if it is network card, maybe in the beginning you are buying some IEEE 802.3 Ethernet card. Okay, so this Ethernet card, we'll talk about that soon. Then we have this wireless LAN. If we have the wireless LAN, then it is basically IEEE standard 802.11, and if it is broadband wireless LAN, this is IEEE 802.16. So these are some standard. Okay, now in local area, this Ethernet technology that we are saying, that its job is basically LLC, that is data link layer, basically data link layer and MAC layer job. So that means data link layer basically divided into two sub layer. One is called data link layer, and another is MAC layer. So this Ethernet technology is basically providing, that means the network card that we purchase from the market, it basically gives the some task of data link layer and something called MAC layer. That MAC layer is medium access control, and data link layer is basically, you remember that it tries to see that the sealed envelope, so that metaphorical example that I gave, and it basically see that when it receives the information, when you pass this information to the physical media, let's say this is the physical media, maybe let's say cable or something, from this network, we have the let's say this is Ethernet card or network or LAN card. We sometimes say LAN card. This LAN card, and connected through cable. So this is basically going to the connected. So this is a cable, let's say. Okay. Now the idea is this Ethernet technology. What one task you do is MAC, medium access control, and how MAC works. So generally this cable is shared by different other computers also, or device also, right? Maybe connected by another networks, maybe connected by another networks. So one job, this MAC layer do, that, okay, so it ensures that which devices, either these devices or these devices or these devices, which devices, use this cable or use this media, okay, to, send the information. So this is called, medium access control. Okay, so how it does? So basically, if a stations means, let's say mobile or computers, if a stations wish to send a frame, we are saying it's basically a frame or packet, whatever you say. So if you wish to send the data, first you listen to the networks, okay, and if there is no traffic, then he send the frame. Okay, but how about it is possible that multiple stations, they may try to send the data. So what happens? So all the stations let's say waiting, but then suddenly maybe 2 or 3 stations send their data at the same times. Now so we need to do something called that. Okay, first before a station sends the data, he basically check the channel and see that if there is any data on this channel. If there is any data, then he doesn't send. And if there is data, he sends. Now, if he find that, okay, when he sends the data, now let's say this is our channel that we are saying, and this card, LAN card, or let's say this device, send the information, and when they send information, the signal level, voltage level is maybe let's say maybe 1 millivolt, and at the same time, maybe this device also sent the data is also maybe 1 millivolt. Now, right after it sends the data, and if it detects this information basically become 2 millivolt, So definitely this guy and this device knows that, okay, maybe some other device also sending the data, so I'll have to stop this. So, and then again he tries later on, because he knows that because my signal was 1 millivolt, but I am checking it's 2 millivolts, so that means some collision happen, so I'll have to stop my transmission. So this is called something called carrier sense multiple access with collision detections. That means before we transmit the data, we'll have to first check our medium that there is traffic or not. That is called carrier sensing. And if there is a data already in the channel, so that means if I can detect some collision, then I'll have to stop this one. So this is called carrier sense multiple access. So this is done by this Ethernet technology. Okay. So in this way, the computer cards in our computer, it basically detects the signals. Now other works is that when it tries to send the information to a receiver, so definitely there will be some error, as I told you that some other body can see it, so it sealed the envelope. So that sealed envelope is made by this extra information, that whatever information we are sending, the data we are sending, based on our data we generate some signature. So this is mathematically done, so we will not explain these things now here. So you just say this is for some error controlling or error checking, these things is, or error detection, this kind of CRC we put. So this CRC means cyclic redundancy checking. Okay, so whatever, so ultimately this is how a total frame look like in that frame by frame data that coming from our Ethernet LAN. It looks like this one. This means in the beginning we have some preamble header that needed to understand this is an Ethernet frame, and then we have the destination address, that where we will send our information, that destination address, and again this is logical address, not physical address. And this was that which source it is. This is a source address, so 6-byte source address and 6-byte MAC address, and this is the type or length, and this is our data. Original data is basically long data, right? So this is called data frame. Now this is some idea I gave you. So LAN usually that how LAN usually works. Maybe there are some central hub, we say, and then maybe you are thinking that this is one computer and maybe another computer, this is another computer. This kind of star topology generally is good, right? And recently we say this is not hub, rather we say this is switch. And the maximum data rate, the early Ethernet was 10 Mbps, but later on it basically improved. But most widely used is basically the fast Ethernet. So this is we say this fast Ethernet network, we say 100 base TX, and this is very popular. This is 100 Mbps. And of course there's other version of that. This is basically 1 Gbps. Now we talk about something on access networks. Okay, access networks. So access networks means that we have the LAN that, let's say, our home or office, but this is a LAN, right? Let's say in our home we have in our office we have 10 computers that connected by a LAN, but that's not the internet. Internet basically coming from some ISP or external internet we have to connect, right? So how to access this internet in our office or LAN or in our home? So this is called access networks. Now these access networks, initially it was dial-up networks. A very early internet access was very often it was by these dial-up networks, and this used basically the telephone line. Telephone line means public switched telephone networks. So this is PSTN, and this PSTN, that is our telephone line, was used that from our computer were connected by we had a telephone line, and then with this telephone line we had some modem, and that was connected by some ISP, that is internet service provider. Now definitely the telephone line is basically analog signal or voice signal, so that's why to transmit the digital data we used modem. And still in this world, in many countries, still even in America also there are some dial-up connections. But mostly we don't know about this dial-up connection anymore. But it was the case initially. But in the dial-up connection, it took a lot time before even internet is connection start. And the modern dial-up modems basically even might have up to 56 kbps. Kbps means the kbps, but it has high latency, 300 MB millisecond or something. And then we have phone line noise, and there are some other quality factors. So definitely delay and connection speed is really very horrible. So we can't use that kind of low speed and a high delay for our multimedia applications. So to solve this problem, in 80s, International Telecommunication Union, that is ITU, they started to develop something called ISDN, or called Internet Service Digital Networks. So initially, they came up with narrowband ISDN, and so it was the speed was up to 128 kbps, and then they recommended or developed broadband ISDN. The broadband ISDN has two sort of interface. One is basic rate interface, and another is primary data rate interface. The basic data rate interface was achieving around 144 kbps, and primary data interface was able to have even up to 2 mbps, 1.5 mbps, 2 mbps, that one. And this PRI was consistent with some other kind of industrial standard called T1 standard. So, and this other version, they also had something called standard E1 standards, which has up to this 2 mbps things. And interestingly, this PRI, this was basically North American and Japan, and the other versions also had in Europe. So there are different kinds of things. You can go through and you can read it to clarify. You will understand it. So then this ISDN and this dial-up is really old, and perhaps we are not using now. So now the things came is digital subscriber line. Of course, this digital, or DSL, we say DSL, digital subscriber line. Now this access networks, this is definitely access networks, by the way. This access networks technology, it also use this existing telephone networks, telephone line, to transmit the modulated digital data. But it uses some very sophisticated technology called discrete multitone technology. So this discrete multitone technology was used for better transmissions and even in noisy channels. So that's why it provided higher data rates. For example, if the twisted pair copper wire, it is basically copper wire, right? This one, the DSL that use the telephone networks, twisted pair copper wire. So this is basically the data is 1.544 Mbps, and maybe the wire size was 0.5, and distance was covered up to 5 kilometers. But if it is high data rate 6 Mbps, then the distance definitely become less. So digital subscriber line went through different evolution. So it had the version of HDSL version. This is high data rate digital subscriber line, and the data rate was 1.5 Mbps to 2 Mbps, and it was duplex mode. Then we had HDSL. This is single line digital subscriber. It is also duplex mode. By the way, what is duplex mode? Duplex means your transmission and receptions will occur simultaneously. So that's the duplex mode. And then it comes another popular things, that is ADCL, that is asymmetric digital subscriber line. So in ADCL, the uplink and downlink was different, because depending on the applications we saw, and then at the time when it came, we saw that in most of the cases maybe we consume data more than what we basically provide the data, right? So downlink speed was more. It was basically downward directions at the time. So it is basically up to 9 Mbps, and the upload speed was some kbps. And this another version is very high data rate digital subscriber line. It is something like this, 13 to 52 Mbps download, and 1.5 to 2.3 Mbps upload speed. And this ADCL is one of the most widely used access networks technique. So then so another access technique is hybrid fiber coaxial cable networks. See, we understand that our home has telephone lines, and definitely these days we don't have telephone lines, but in our homes or many homes now is a very very readily available is cable TV networks, right? So now then the telephone company, they thought, or maybe the internet company, they thought, how about using that cable TV networks? And so what they did is this home, they have this cable, coaxial cable networks. That means they have some TV, right? That kind of things. So that means they were connected through this coaxial cable. Now the design came up with, okay, so we can use this coaxial cable for internet services. So maybe let's say for every 100 or 200 homes, so these networks, and then we place some sort of we say optical network unit. So this is maybe placed somewhere in our neighborhood, this optical network unit. So this coaxial connected to these networks, and this ONU is connected to the ISP, the main internet provider or core networks. Okay, main internet provider or core network, that where this internet is actually is also occurring, right? This internet, you can say this is the internet. So now that optical network unit, that is ONU, and this core networks is connected through optical fiber. So that's why we are saying this is hybrid fiber coaxial cable networks. So that means this is our internet, internet, the facilities, and this is optical fiber, and this is coaxial networks. So this is called hybrid techniques. So this is one source of access networks, and definitely this is very widely used also. So these two forms, one is I would say DSL, this is digital digital subscriber line access networks, and ADC and this cable networks, cable TV networks. These two are very very prominent and dominant in the market. So cable modems can be used for bidirectional data communications via radio frequency channels, and definitely hybrid coaxial networks. We need a modem, of course. You remember the very very fast diagram that we saw maybe over here, that to use our home coaxial cable networks on those, we need this kind of modem, or this kind of modem, so that it provides the required conversion, right? Data conversion from analog to digital to analog, or maybe suitable for coaxial cable, and back to the fiber characteristics, so that kind of things. Okay, so we understand that. And then peak connection speed of cable modem is basically up to 30 Mbps. Definitely this is faster than DSL access, but we'll have to ensure that the cable internet access basically the shared among many neighborhood, right? As you saw that here, that this one maybe optical fiber is basically, or maybe one optical node basically shared among many homes. So that's why cable TV network might be slower compared to our DSL things, because DSL based telephone line is basically dedicated. And as I told you that DSL and cable access have dominated home internet access around the world. So then next concept came is, how about fiber to the home, that we don't want some hybrid both coaxial cable and the fiber. We will directly connect core network to our home by fiber network, or we will say that from the core network, this is the core network, from the core networks, this is our home, so we'll connect through the fiber networks. Or maybe we can say that, okay, or maybe maybe less number of home, maybe 5, 6, or same, we will have one neighborhood, then again we'll be connect some ADCL, ADCL connection from here to here. Okay, so fiber from here to some neighborhood, and then ADCL connections from here to here, or maybe directly core network to fiber. So we are saying fiber to the home, see, fiber to the home or fiber to the neighborhood. So, but definitely most of the buildings are old, so maybe we don't have proper infrastructure for that. But many new high-rise buildings have already had built fiber access, so we can directly access fiber over fiber to the home. So, and this fiber to the home is basically not just theoretical, it's also practical. For example, American AT&T, they have something called UVerse service. This is basically an example of this FTTH or FTTN, and different kinds of connection speed, and the services that provided by U service is basically like that. If you like to have subscribe just for video chatting, you have this kind of speed, and online gaming, and download movies, emailing, large file watching video clips, online meetings, and maybe web surfing, emailing, social networking. And for each one there are different kinds of profile or services, right? For example, if you do the social networking, maybe this kind of service you can use, right? 3 Mbps, if you pro users and elite user 6 Mbps, max user is 12 Mbps, max plus 18 Mbps, turbo users is 24 Mbps, that kind of things, right? So this is something that it was good to discuss, and in the next part we'll be discussing on internet technologies and protocols.